Hello, you're welcome. Today we're going to evaluate the integral of x squared multiplied by the square root of 5 minus x raised to the power of 6 dx. This integral is owned by prime Newton, right? But today I'm going to show you guys my own solution to this problem, okay? So here we're going to write this integral as, this is going to be same as 1 by 3, right? So we're going to have 1 by 3, then multiply by the integral of 3x squared, then multiply by the square root of 5 minus x raised to the power of 6, and then dx. So let's see the outcome. So here, this is I is equal to, this is 1 over 3, multiply by the integral of, this is same as square root of 5 minus. So this is going to be same as x cubed whole squared, right? And don't forget we have 3x squared attached to the dx. Now let us make the following substitution. So we're going to let x cubed equals the variable t. Now differentiate both sides, we get 3x squared dx, that this is going to be equal to just dt, and we have exactly 3x squared dx here. So this is really cool. So our I is going to be equal to 1 by 3 multiply the integral of just the square root of 5 minus, this is going to be t squared, and then dt. Okay, now let's call upon trigonometric substitution. Okay, so here we have 5, we have t squared. Let's think about when we have 1 minus sine squared of theta, which is giving us cosine squared of theta, right? So using this idea, it shows that we're going to make the sine substitution or the cosine substitution. So let us use the sine substitution. Now with the sine substitution, then our t is going to be equal to root of 5, because when you square it you get 5, then you can take out the 5 which is common, then multiply with sine of theta, then differentiate both sides, we get dt is equal to root of 5, right? Multiply the cosine of theta, and then we have our d theta. So I is going to be equal to 1 by 3 multiply the integral of the square root of, this is going to be 5 minus, so this is going to be root of 5 sine of theta whole squared, and then our dt is going to be square root of 5 cosine of theta, and then d theta. Take the root of 5 outside, so we have I is equal to, this is going to be root of 5 by 3 multiply the integral of the square root. So here we have 5 minus square root of 5 squared, there is giving us 5, then sine squared of theta, here we are left with cosine theta, and then d theta. So here our I is going to be equal to square root of 5 divided by 3 multiply the integral of the square root. So here we're going to have 5 into brackets 1 minus the sine squared of theta, here we have cosine theta, and then d theta. So here I is equal to, this is root of 5 by 3, so take out the root of 5 as well, we get again root of 5, then the integral of square root of 1 minus sine squared of theta, we have cosine of theta, and then d theta. So here I is equal to root 5 times root 5 is going to us 5 over 3, right? Multiply by square root of 1 minus sine squared theta. Remember, 1 minus sine squared theta is cosine squared of theta. So we have cosine, square root of cosine squared of theta. We have cosine theta d theta, and this is giving us 5 by 3. The integral of square root of cosine of theta is just, the square root of cosine squared of theta is just cosine of theta. Then we have the product, which is giving us cosine squared of theta, and then d theta. So we're going to use this nice trigonometric identity that the cosine squared of theta will be same as cosine of 2 theta plus 1, then divided by 2, and then d theta. And when we split, we get 5 by 3, the integral of cosine of 2 theta divided by 2, d theta plus 5 by 3, the cosine of half, and then d theta. So here I is equal to, now this is same as 5 over 6 multiplied by the integral of the cosine of 2 theta and then the theta plus, this is just 5 by 6 again, right? Then the integral of theta, that is giving us with just theta. Now, how do we evaluate the integral of cosine 2 theta? So let's say we have I sub a, which is equal to the integral of cosine of 2 theta, the theta. This is easy enough by making the substitution. 2 theta is going to be equal to x, theta is equal to x by 2, the theta is equal to dx by 2. Now, I sub a is going to be equal to 1 by 2, the integral of, oh, is that cosine? Yeah, cosine of x and then dx, which is giving us, that is giving us the sine of x. So 1 over 2 sine of x and then plus c. Don't forget our sine of x will be sine of 2 theta. So don't forget that. So from here, this is giving us 5 over 6 times 1 over 2, giving us 5 over 12 sine of 2 theta, and then plus theta or 5 theta divided by 6 and plus c. Okay, that's cool. So let's write down what we have. So I is equal to 5 theta by 6, then plus 5 over 12 sine of 2 theta, and then plus c. So let us recall again that t is equal to square root of 5 times the sine of theta, right? So we can solve for theta here. So we get that sine of theta is equal to t by square root of 5. Therefore, theta is equal to the inverse sine of t by square root of 5. What about cosine theta? Can we ever derive that here? Of course, I is equal to, here we have 5 theta divided by 6 plus, this is 5 by 12. Now, sine 2 theta is same as 2 sine of theta cosine of theta and then plus c. You see, so we need the value for cosine of theta, and we can easily achieve that by squaring both sides here. The left hand side sine squared theta will become 1 minus cosine squared of theta. So this is going to be equal to t squared divided by root 5 squared is 5. Then we have cosine squared of theta will be equal to t minus, oh, is that t or 1? That's actually 1, right? So this is going to be equal to 1 minus t squared by 5. Cosine squared of theta is going to be, this is be 5 minus t squared and then divided by 5. Now take the square root on both sides. If you do that, we get cosine of theta is equal to square root of 5 minus t squared divided by square root of 5. Okay, so our I is going to be equal to 5 theta by 6 plus 5 by 12. Don't forget this is 2 sine of theta cosine of theta and then plus c, right? So here this will be same as 5 theta by 6 plus, so 12, 2 into 12 here giving us just 5 by 6, and then we have sine of theta cosine of theta and then plus c. Now we can make our substitutions now. So remember theta, the value for theta, which is the inverse sine of t over root 5. So it's going to be 5 over 6 multiplied by the inverse sine of t by root 5, right? And then plus, this is going to be 5 over 6 multiplied by sine of theta is equal to t by root 5, right? So t by root 5 multiplied by cosine of theta is equal to square root of 5 minus t squared divided by square root of 5. Don't forget our plus c. Now we need to simplify. So here I is equal to 5 over 6. The inverse sine of t over root 5. So here square root of 5 times square root of 5 is giving us 5. Then this 5 gets cancelled with the 5, and then we're left with plus. This is going to be t divided by 6. Then multiply the square root of 5 minus t squared, and then plus c. Don't forget that t is equal to, t is equal to x cubed. So therefore we come up with our solution that I is going to be equal to 5 all over 6 multiplied by the inverse sign of t, which is x cubed, divided by square root of 5, right? Then plus t, which is x cubed all over 6 times the square root of, this is going to be 5 minus t squared will be x raised to the power of 6, and then plus c. So this right over here is our solution. Please, if you really enjoyed this video, kindly do well to support the channel by subscribing, also like, comment, and share.